the I can statement for section 6.2 is I can understand and use equivalent ratios. Equivalent ratios. And the warm-up question is just about some basics that hopefully we're already familiar with. And the first one says, what is the difference between the x-axis and the y-axis? And the hint is V and H. So if you'll remember, when we're talking about the x-axis and the y-axis, the x-axis is a number line that's set horizontally, and the y-axis is set vertically. So the difference here is we get the x-axis, we get the horizontal coordinate first, and then we get the vertical coordinate second. All right. Then it says, do you know how to graph the point -2, 6 on the xy plane? So -2 would mean the horizontal coordinate, or the x coordinate, is -2, and then the vertical coordinate, the y coordinate, is +6. So that's going to be about like that. That's going to be about where that is. And then for part C and D, it says, okay, if we start off with 16/12, or that fraction, that ratio, that rate there, it says, what would that be equal to? So let's take a look at this. This would be 12 would turn into a 3. So the way we turn a 12 into a 3 is we would divide by 4. So we're going to do the same thing here. We're going to take this and we're going to divide that by 4. So we get 4/3. Those would be equivalent fractions or equivalent ratios. If you take this and reduce it, you end up with that. If you take this and you multiply the top and bottom by 4, then you end up with the 16/12. If we take a look at this one right here, this one says 20/4, and let's see, what would that turn into a 5? Well, on this one we just thought, okay, well, we just divide this by 4, or going this way, going the other way, we times by 4. Well, on this one it's a little bit more difficult, but we can kind of change our technique, and instead of looking at the bottom and figuring out how to change one bottom into the other bottom, we can look at the bottom and the top. How would we change from a 4 to a 20? Well, that means the top is 5 times bigger than the bottom. So on this one, the top's got to be 5 times bigger than the bottom, and we end up with 25. Okay, so again, different techniques on each one of these, but you'll notice that we end up with equivalent fractions on either one. 20/4, if we reduce that, or change that to an equivalent fraction, that would be 25/5, which, again, if we reduce this side, we'd have a 5/1 over here, and we'd have a 5/1 over there. So they're definitely equivalent fractions. This one doesn't reduce as much as this one does, to see that they're equivalent fractions, but the same ideas can be used there. Okay, so let's talk about ratios again. Ratios can be represented in many ways. We can describe them in words. We can use words to describe them. We can write them using numbers. Okay, and we can even do them with a graph. And we can organize the numbers in tables. So there are a couple different ways that we can talk about them and we can describe them. We can use words, we can use numbers, and we can describe them with a graph. And we can organize the ratios in a table. And ratios can be used to solve some pretty interesting problems. So we're going to take a look at one of those problems right here. I kind of made this up just to see if we could kind of see some of these relationships. So it says Annie kicks Malik's butt whenever they run laps. So they're in gym class or whatever, and Annie she can run circles around Malik. In fact, it says for every 2 laps Malik runs, Annie runs 6 laps. And for part A, it says write the ratio of Annie's laps to Malik's laps. Okay, so Annie runs 6 laps, so it's going to be 6 laps to 2 laps. And it says write it in all 3 forms. So we could write it this way, we're using the word 2. We can write 6 to 2, or we can do 6/2. And again, we could use that label on each one of them. So this is 6 laps to 2 laps. All right. So we're going to leave it like that. We've written it in all 3 different forms. And when we said pay attention to the order, what we mean is it says Annie's laps to Malik's laps. So you'll notice that we've got Malik mentioned first here and Annie mentioned second here. That's totally okay. When we're describing this ratio, it says Annie's laps to Malik's laps. So those have got to go first. Now, we may at some point go ahead and simplify this, but we're not going to do that right now because of the way this problem is set up. So it says use the table to write the original ratio and its next four equivalent ratios that use larger numbers. And this is a key right here, and it says pay attention to the order and check each ratio. So we've got Malik right here. Malik is going to run 2 laps, and then for every 2 laps Malik runs, Annie's going to run 6. So we've got those original 2 numbers that are used in that original ratio right there. And then we want to come up with equivalent ratios that use larger numbers. So if we were going to make this bigger, we could try and make that a 3, but that's a little bit more difficult. So let's do this. Let's make that a 4. And if that were a 4, if we were doubling this one, then we'd want to double that one. So this is going to be 12. So this is going to be 4, and this is going to be 12. Well, let's keep counting up by 2 right here. So let's make this a 6, and let's make this an 8, and make that a 10. And what's going to happen here is if we're counting up by 2 here, we're going to be counting up by 6 right here. So this is going to be 6, and this is going to be 18, and this is going to be 24, and this is going to be 30. And it says check each ratio. So let's check each one of these ratios. This was the original ratio of 6 to 2, 12 to 4. Those would simplify to be the same thing, so that would be fine. 18 over 6, 24 over 8, and then 30 over 10. And when we're checking those ratios and we say they simplify, each one of these you'll notice will simplify to 3 over 1, 3 over 1, 3 over 1. 6 goes into 18 3 times, and 6 goes into 6 once. Same thing here, 8 goes in here 3 times, 8 goes in here once, and of course with 30 and 10 we could write that as 3 over 1. So they're all equivalent ratios. So it says graph the 5 ratios from the table you created in part B. Be sure to label the axes. Okay, so let's do this like we do in XY plane. So Malik is kind of taking on the role of an X, and Annie's kind of taking on the role of a Y. So we're going to have Malik on this axis, and this represents Malik's laps. And the vertical axis over here, this is going to represent Annie and her laps. Okay. Now I'm going to go through and I'm going to count by, let's count by 2. So this is going to be 2, 4, 6, 8, 10, 12. We don't need to go any further than that. So I'm going to 4 and 8 and 12. That's going to take care of the horizontal axis. And then we're going to count over here. So let's count by 2's again. So this is going to be 2, 4, and 6, 8, 10, and 12, 14, 16, 18. So I'm kind of marking these off so we can kind of keep track and we don't have to count every one of these boxes here. So this would be 20, 22, 24, and then 26, 28, and this would be 30 up here. So we're going to graph those ratios on here. So just like we learned how to graph XY coordinates, we're going to graph Malik, and then we're going to graph Annie. So 2 would correspond to 6. So 2 laps for Malik is going to correspond to 6 laps for Annie. 4 laps for Malik is going to correspond to 12 laps for Annie. So that's going to go right here. Let's keep following this up. So this is going to be 6 for Malik and 18 for Annie, 8 for Malik and 24 for Annie. And you might notice what's happening here as we do this last one, 10 and 30 laps right here. Kind of an interesting thing happens here. We get this nice straight line here. Okay, so we're going to kind of extend ourselves down to this part. And it says this graph shows us we're going to call it this. We're going to say it's a picture of the relationship between Malik's laps and Annie's laps. But we can kind of deepen understanding by doing a few more things. We can kind of deepen our understanding of this relationship. So we've got a picture right here of this relationship, and we've got some numbers right here, and then we've got a verbal description up above. So then it says to do this: draw a straight line that passes through all 5 points and extends to the edges of the graph. So we've got 1, 2, 3, 4, 5 points, and this one already is at the edge of the graph, but that one's not. So here's what I'm going to do. We're going to draw a straight line. Well, let me back up here. We're going to draw as straight a line as we possibly can, and we're going to go to the edges of each graph. So it's going to look something like this, okay? And it says what is the point where the line starts? So that starting point looks like it would be about right there. So that starting point would be 0, 0. All right. Let's see. And does that line end on the other end right here? Well, this right here would be where the line starts, because this would be like 0 laps for Malik and 0 laps for Annie. Would there be a point where this other one ends? And I mean, on the line there probably wouldn't, but these guys are going to get tired eventually, so the line probably would end in if it were really representing the number of laps that they could run. And it says describe what this point means in this situation. So again, what this means is, since it's 0 on the horizontal axis, if it's 0 on the Malik axis, Malik runs 0 laps when Annie runs 0 laps. They haven't gone anywhere, okay? They haven't started running or are running laps or anything like that, okay? Then what it says is, moving horizontally vertically then horizontally, how would you get from the point 2, 6 to the point 4, 12? So I'm going to change colors here to do this. So we're going from this point right here. We're going from 2, 6 to 4, 12. So we're going from this one to this one, and it says move vertically then horizontally. So we would have to go up, and then we would have to go over. So, and then it says from 2, 6 to 8, 24. And I'm going to change colors for this from 2, 6. So from this one to 8, 24. So to that one right there. Now, so that we don't get confused on this right here, I've drawn those movements in blue. And what I'm going to do is I'm going to count those. So we're going to go up 1, 2, 3, 4, 5, 6. So we started at 6 and we went up to 12. So we went up 1 dot, 2, 3, 4, 5, 6. So we're going to do up 6 and right 1, 2, right 2 units, okay? And then in green, I'm going to do the other one. So this is from 2, 6 to 8, 24. So that's from this one up to 8, 24. So I'm going to draw this one like this. So again, it says go vertically. So we're going to go all the way up here, and then we're going to go over here. So let's count these. Again, this was 6 to right here. That would be another 6 to right there, and another 6 to right there. So this is going to be up 18 and right. Let's see, how far are we going to go? 2, 4, 6. You can count them. 1, 2, 3, 4, 5, 6 spaces. So right 6 there. Okay. And then what it says is write these movements as a ratio. Vertical movement on top and horizontal movement on the bottom. So we're going to do 6 over, whoops, let me do this one in blue. We're going to do 6 over 2. And we're going to do the other one. The other one is going to be vertical movement on the top. So we're going to be up 18 and then right 6. So that's going to be 8 over 6. Now, what do you notice about the simplified answers to part E? So let's go ahead and simplify each one of these. So if we simplify this, this would be 3 over 1. And if we simplify the other one, that would be 3 over 1. Now remember what the vertical is. The vertical would be Annie, because that's up and down, and the horizontal one would be Malik. So this is going to be, whoops, again I'll change colors here. So this is going to be Annie up here, Malik here. So this is Annie, and this is Malik. Okay, so if we take a look at that simplified answer right here, that simplified answer there, and this simplified answer here, what do we notice about those? Well, they turn out to be exactly the same. They're 3 over 1. In fact, they turn out to be the simplified ratio for each one of those points. So we're going to write this down. We're going to say all the same. Okay. So what this means is if Malik ran 1 lap, how many laps would Annie run? So if Malik ran 1 lap, how many would Annie run? Well, that means Annie would run 3. So let's go back here and let's consider this original one right here. The first point on our coordinates is Malik. So this would be 1 and this would be 3. So Malik would be 1 and Annie would be 3. So if Malik ran 1 lap, would Annie run 3? So let's go up here and I'm going to zoom in on this right here. And again, this isn't perfectly straight or anything, but if Malik ran 1 lap right here, Annie would run 1, 2, 3. It would be that point on that line. So I'm going to zoom back out here and we're going to take a look at this and let's see, does that actually fit this pattern? Well, it's right on the line. So the answer to that question is this point on the graph? The answer there is yes, it is. So again, this is a way where we can go through and we can look at a situation where we've got a ratio that's given. We can come up with some equivalent ratios, organize them into a table, and we can graph them and we can take a look at it. And in this particular situation, we get a picture that looks like this. It's a nice straight line. Okay, so the graph makes a line, and then we can see all of these points that were the original ones, here, 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 and here. They're all on the line, and if we do this vertical and horizontal movement and come up with the same type of ratio, we get this point right here. We get 1, 3, meaning Malik runs 1 lap for every 1 lap that Annie runs. So as you're doing today's assignment, all you need to do is just kind of be familiar with what we've done here and just kind of explore this relationship and how we can represent it. Not only go from the words and then the numbers and graph it from that table, but kind of think about how all of these things might be related to one another as you go through and do that.